Hi, I'm Kory Stalsberg with Southwest Technical College out of Fenimore, Wisconsin, and today we are going to be demonstrating a rainfall simulator. So the way that the simulator is set up here, yesterday we pulled samples out and you can kind of see the pictures in the back of what the actual fields look like that we took the samples out of. We have a alfalfa crop here, alfalfa grass mix that was established last spring. So it's in its first full year of production, and there's a lot of tap roots here. We have a lot of high quality soil structure that should demonstrate a lot of water holding capacity. Next here we had a crop of winter wheat that was harvested here about 3 weeks ago. You can see that there's some regrowth wheat coming back up. They did inject manure. You can see that in the pictures here of the manure that was injected. So there might be a little bit of compaction with that particular field because of the manure equipment, because of the harvesting equipment, and as well this field has not been tilled since would have been last fall when that winter wheat was established. In the middle here we have a soybean field that was roller crimped rye prior to planting. It was planted May 28th, and you can see that there's a real heavy rye residue on top of the soil, which aids in a lot of protection of raindrop impact. So predicting that this will not have a lot of runoff, but and a lot of water infiltration as well. Our fourth sample here, this is a rotational graze that's been in paddocks since about 10 years now. So this has a real heavy thatch layer on top, as well as a high amount of organic matter, probably in that 5% organic matter or even a little bit better. My prediction on this one is it is going to hold a lot of water. It's not going to let water run off, and it's not going to let water infiltrate as much because that heavy thatch layer is going to hold that water in place and allow it to be available for that crop. Our last one here is a organic corn production here taken between the rows. You can see there's not a lot of cover on that. There might be some wheel track compaction as well between the rows because of the cultivation practices and the tillage practices on that particular field. I did run this already. I put about 2/10 of an inch of rain down, and you can see that this one is already having a little bit of runoff here. So what we'll do here is we'll run this as for about 10 or 15 minutes. We'll try to put down about an inch of rain to demonstrate for producers of the different types of cover and how that affects infiltration and runoff. So you can see how the simulator works. It's demonstrating a pretty substantial rain event. And I put a rain gauge in each of the plots just so we can see how much water is actually being put down. Like I said before, we did put down about 2/10 of an inch of rain just to weten that soil up a little bit. And that way we can see, as the rain event is occurring, we see some of that runoff and that infiltration. Also, you'll notice that all of the samples are set up at a little bit of a slope. It's actually about a 25% slope here, which causes excess runoff if we don't have something on the ground, okay? Something growing on the ground with that steep of a slope is going to cause a lot of runoff. Ideally, we want as much water going into the soil as possible, so having that cover on there or some type of a growing crop on there is going to reduce that rain impact or that raindrop impact, as well as allow those root channels to grow into the soil, which allows water to infiltrate faster. So we just put down about a half an inch of rain in that short period of time, and you can see that we are getting some runoff on our corn. We're getting a little bit of runoff here on our roller crimped rye example here, but the other three are pretty much absorbing everything that's coming down. A little bit of runoff here on that winter rye crop. And if we do peek back behind here, okay, so on the back side here, this is the water that has infiltrated into the profile, so available for roots to absorb. And you can see our middle example was that roller crimped rye, how much infiltration we have there. So that soil is letting that water percolate down into the profile at a very rapid rate. So that's going into our soil profile and is available for plants to use. We want to see the water back here. We don't necessarily want to see it out front, and we want to see as much of it in the profile as well. So that little profile of the sod is holding a lot of water so far. The alfalfa is holding a lot of water, and this one is going to have the most water available for those crops to grow. So it's really a neat demonstration for producers to have that visual information right there in front of them. So we're able to demonstrate different crops and different practices that are utilized, and then we see the results and what they have on the soil and the water that's being infiltrated into our soil profile. If you have any questions related to farm business and production management, you can go to our Southwest Tech /FBPM website, and all of our contact information is there. Otherwise, cell phone, text, call 608-379-4076. Thank you.